This one is going to be about long division, polynomial long division. As you can see, we're starting off with just a regular number example, but then we'll do one that has variables in it as well, because if there's anything that would make long division more fun, it's adding the alphabet to it. Uh, you guys, hope pretty much everybody has done long division, I think, at some point in their elementary school career, but then usually we get lazy with using calculators, and I don't know if you really want to call it lazy because it goes faster than doing long division, so it's really just being more efficient. But if we start putting variables in there, that can be hard for most calculators to be able to do that, so then we're kind of left to our own devices. So first off, we kind of need to probably relearn long division a little bit here. Remember, when you set up long division, it's actually the second number, the one you are dividing by, that goes outside the box. So the idea here is we want to start with the 1 and say, okay, does this 1 divide by 4? Well, it doesn't. So because of that, we go on to the next number and say, okay, can 12 divide by 4? Well, yeah, 12 can divide by 4. That gives us 3. So that's the beginning of our answer. Then we take 3 times the 4 on the side, give us 12, and subtract. That cancels out, so we drop the next number down. Then we restart again and say, okay, does 8 divide by 4? Yeah, 8 divides by 4, that gives us 2, so that's the next part of our answer. 2 times 4 is 8, so we subtract away 8, and we drop our last number down. Well, does 5 divide by 4? Well, yes, but not evenly. It's going to be 1 and then some extra. So we put the 1 there because that's the whole number, right? That's how many times 4 can go into 5 is 1 full time. 1 times 4 is 4, and so when we subtract, we end up with a remainder. Now, depending on what you guys remember, there were multiple different ways that you guys were taught to deal with remainders. When you first did long division, teacher probably just said, just put remainder of 1 off to the side, call that good. And then later on, they probably had you put the decimal point and start adding some zeros to drop down to make it 10, such like that. Well, I don't want to do either of those things. What we're going to do is we're just going to write it as a fraction. We're going to make this a mixed number, which I don't really care for mixed numbers, but it works better for what we're about to do with the polynomials. So basically, remainder, root word remain, meaning what's left over, we literally have a 1 stuck down here at the bottom that we're supposed to divide by 4, but it just doesn't work out. What we're going to do is we're literally going to write the math representation of 1 divided by 4. It's just a fraction, right? 1/4 literally means we have 1 divided by 4. And so that'll be our answer, is 321 and 1/4. Now, hopefully that made somewhat of sense or was a little bit of a refresher, but if not, that's fine as well, because I've written out some steps here for polynomial long division, so it's not a big deal. What we're going to do is we're going to go through this example here of x to the third plus 5x squared plus 6x plus 9 divided by x plus 3. Let's see if I can make this line thinner. Yeah, okay. Just like with the numbers, x plus 3 is the part that goes outside the box, whereas x to the third plus 5x squared plus 6x plus 9, so we're going to put inside the box. As the steps say, we're going to take the first term inside the box and divide it by the first term outside the box. That would be x to the third as the first term inside the box, and x as the first term outside. X to the third divided by x would be x squared. That is the beginning of our answer. Now you'll notice that I wrote it above the 5x squared. That's just to line things up. It doesn't really matter. It's not a rule that you have to follow. I'm just trying to be a little organized with my space here. That's all. That's step 1. Now step 2 says to multiply that part of our answer to every term outside the box. This is a bit of a weird part because you never had to do this whenever you were just doing basic long division in elementary, because you only ever had a single number outside the box. Well, here, we're not dividing by just x or just 3, we're dividing by x plus 3. So because of that, we have to take x squared times x to give us x to the third, but we also need to take x squared times 3 to give us 3x squared. On top of that, compounding the weird part of this, or I shouldn't say weird, but the different part from if you remember doing basic long division back in the day, the other weird part of this is we need to subtract just like we did before, but now we have a quantity that needs to be subtracted because there's two terms down there. So it's not just x to the third minus x to the third to cancel out, but it's also 5x squared minus 3x squared, which means now we have a 2x squared plus the 6x that we can drop down plus the 9 that we can drop down. A little odd, but if you're able to follow along with that, that's all long division's going to be, because step 4 is go back up to the top and repeat. Meaning, step 1 says to divide the first term inside the box by the first term outside. Well, I have a new term, new first term inside the box. The x to the third is gone. 2x squared is now my first term inside the box. So I have to divide that by the x that's outside. 2x squared divided by x is 2x. So that's the next part of my answer. Again, step 2 says I'm supposed to take what I've written above the line, the new part of my answer, and multiply that to everything on the side. So now I'm taking 2x times the x over here. I'm not going to keep that arrow there. 2x times x would be 2x squared, and 2x times 3 would be 6x. If we are subtracting, which we should be because that's step 3, both of these are going to cancel out, which means we're left with just the 9. Now if my new first term inside the box is 9, that's not going to help a whole lot if I'm asked to divide by x. Can't really do that. I'd be left with a fraction. That means 9 is going to be our remainder. Well, in the same way then that we had the 1/4 on the other problem, where we took our remainder and just put it in a fraction over whatever we were dividing by, to finish out our answer here, we're going to take our remainder and we're going to put it over what we were dividing by. In this case, x plus 3. And that would be our answer for long division.